Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Crossing a Line by Royston D.A. And here are the rules. Excuse me. We have standard Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have German whisper lines, where digits along the green line must differ by 5, at least 5. Yeah, that seems to be yeah. It has to be at least 5. It cannot just be by 5. So that's a little typo there. Yeah, just make sure you just fix that for the rule set. Um, we have modular lines where every set of 3 digits along... So, okay, let's look at an example. So, for example, if this were 3, this would have to be an 8 or a 9, because those are the only digits that are 5 or more away from the 3. We have modular lines, where every set of 3 digits along the teal line must include a digit from the set 147, a digit from the set 258, and a digit from the set 369. Or essentially 1 modulo 3, 2 modulo, a digit from 1 that is 1 modulo 3, a digit from a set that's 2 modulo 3, and a digit from the set that is 0 modulo 3. That's why it's called a modular line, because they are essentially taking the modulo values of if you divide by 3. So, for example, you could have something like 7, 2, and 3, and that would be valid because we have one digit here that is 1 modulo 3, which is a 7, one digit that's 2 modulo 3, which is the 2, and another digit which is 0 modulo 3 in the set of 3 digits, which is 3. We also have entropic lines, which is kind of similar, where every set of 3 digits along a peach line must include a digit from 1, 2, or 3, 4, 5, or 6, or 7, 8, or 9. And it's called entropic because it's usually sort of thought of as like a thermometer sort of like thing, where you have low, middle, and high sets instead of essentially modulo sets. So if you look at the keyboard, you could divide the modulo sets from left column, central column, and right column. You could look at the entropic lines as rows, or as, so you have the low row, which is 1, 2, and 3, the middle row, which is 4, 5, and 6, and the high row, which is 7, 8, and 9. So as an example, you could have something like 7, 6, and 3, and that would satisfy this entropic line, right? Because one digit is from the low set, one digit is from the middle set, and one digit is from the high set. And this occurs for all 3 digits along entropic lines. And finally, we have Kropke dots, where cells separated by white dots are consecutive and cells separated by black dots are in a 1:2 ratio. So, for example, if this were, say, a 6, this would have to be 5 or 7 because these digits are consecutive. If this were a 2, this would have to be 1 or 4 to maintain the 1:2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so how do we want to tackle this? Well, let's go from the black Kropke dots. Anytime you have 2 black Kropke dots separating 3 digits, all unique, you know it has to be either 124 or 248. As those 3 digits, right? Because those are the only digits which have, basically, if you have any digit which has a 1:2 ratio with 2 other unique digits, it can only be 2 and 4, right? 2 can be next to 1 and 4, 4 can be next to 2 and 8. So this is a 2 or 4 here. This has to be 1, 2, 4, or 8, and this has to be 1, 2, 4, or 8. But we know the rest of the column cannot contain 2 or 4 because one of these digits must be 2, and another digit must be 4. What else do we have? These digits. Okay. Let's continue with these. On a German whisper line. Yeah, let's look at row 5. On a German whisper line, you cannot have the digit 5 be on a German whisper line, because if you subtract 5 or more away from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more, you get 10 or more, which are not a digits. So 5 has to be one of these digits here. What else does that? 5 cannot be here, and 5 cannot be here because those are on German whisper lines. These digits they are next to 2 unique digits on a German whisper line. Actually, all of these digits are next to 2 unique digits on a German whisper line. So they cannot be 4 or 6. Right? Because if they were 4, it can only be next to 1 unique digit on a German whisper line. Same with 6. So this must be a 1, 2, 3, 7, 8, 9 quintuplet. That leaves these as 4, 5, and 6. Since this is 4, 5, or 6, neither of these two can be middle digits. Because if they were a middle digit, that means that in this set of 3 digits, you have 2 digits that are for middle digit, which is when we only can have 1. So this must be the 5 then, because 5 cannot be either of these cells. Well, where can 5 be in the rest of row 5? It has to be here. So this is 5. This has to be a high digit or a low digit in the sense of the entropic line. So this is 1, 2, 3, 7, 8, 9. This is 1, 2, 3, 7, 8, 9. These must be the opposite sets. So we're going to mark this as green, and this is orange. Therefore, these must be the opposite sets of this one, because 7, 8, and 9 would not be possibly be next to 7, 8, 9. So they have to be the opposite set. So this is green. This is green. We're marking this as orange. This is orange. These then have to be green, and these must be orange. So this has to be green here because in this set of this set of 3 digits, we already have the middle set. This is 5, and we have one must be orange, and the other one must be green. Let's see. So where are the 4 and the 6 in row 5? They have to be on the German whisper line, and therefore there must be next to, respectively, 4 must be next to 9 and 6 must be next to 1. But we don't know which one's which. So this has to be 1, 4, 6, 9, 1, 4, 6, 9. This cannot be 1 or 9 because it's consecutive with 2 other digits, and 1 is only consecutive with 1 digit, so is 9. So this has to be 4 or 6, which means it's next to 1 or 9. Same with this. This has to be 4 or 6, which means it's next to 1 or 9. That 1, 9, 1, 9 pair eliminates 1 and 9 in the rest of the row. So this must be 2, 3, 7, 8 here. These are, okay, instead of orange, we're going to make these, I guess, pink. Because I usually use green for middle digits in entropic lines. So this is green. So this cannot be 4, 5, or 6. So either this orange or this pink is essentially a low has to have a 4 or 6. Because this cannot be 4, 5, or 6. These are both on German whisper lines. So this then, neither of these can be 5. This can't be 4, 5, or 6. So that means we have 4 or 6 in one of these 3 digits. Well, it can't be here because it's next. Well, it could be here. So it's either one of these two. We're not sure which. Either way, if this is 4 or 6 or this is 4 or 6, we don't know which one. So this is also the same here. This can't be 4, 5, or 6. It's 1, 2, 3, 7, 8, and 9. This is 1, 2, 3, 7, 8, and 9. So out of these 3 digits, where's the middle digit? It has to be one of these. So it has to be 4 or 6 here. But we don't know which. This is 1 or 9. Okay. So this has to be the same low, middle, high set as this one. Actually, this is 4 or 6. That can only be consecutive with 3 or 7. Same with this one. This can only be consecutive with 3 or 7. That 3, 7, 3, 7 pair eliminates 3 and 7 in the rest of the row. So this is a 2, 8, 2, 8 pair, which eliminates 2, 8 in the rest of that box. These then must both be consecutive with 5. So this is 5. This is 5, right? Because it's either 3, 4, which makes this 5, 7, 6, which makes that 5. So this is a middle cell. We already knew that. This is a middle cell, so it must be 4 or 6. So this is green. This is green. This is obviously green, and this is green. If this is pink, this must be the same set, right? Well, same set. Right, so it's if this is 3, this is 4, and that forces this to be 9. So this would be the opposite set as this one, as the pink. So this would be orange, and this must be pink, right? Because this must be orange, right? And this must be the pink version. That means this is orange. This has to be orange also, and this must be pink, which makes this pink. Therefore, this must be an orange left. This is orange. This is pink. Orange, pink. This is orange. And the reasoning is because for this set of 3 digits, we have one that's from green, one from pink, one from orange. What about from these 3? Well, we lose a green, so this has to match essentially the set that we lose. So that's why we know every third cell is in the same set. So one of these is 4 or 6. We're not sure which. What is this? So this cannot be the orange 1, 9. This is 4 or 6. This has to be 2, 8 orange or 3, 7 orange. We're not sure which. This is 4 or 6. We have 3 oranges already in row 6, so this is pink. We cannot have the pink 3, 7, so this must be 1, 2, 8, 9 in the pinks. Okay. This cannot be 2 or... Okay, this 4-6 pair in this left central box eliminates 4 and 6 in the rest of the box. So this can't be 4. Therefore, this cannot be 1, because that would be 1, 2, and 4 there. So it could be 1, 2, 4 that way, 2, 4, 8, or 8, 4, 2. Either any of those work. This cannot be the pink 1. If this were the pink 1, so say this was essentially a 1, that would force this to be 9, but 1 and 9 are not in the same sets for entropic lines. 1 is in low, 9 is in high. So this has to be 2 or 8 here. 2 and 8 can be only in a 1-to-2 ratio with 4, so this is 4. That makes this a 2 or 8 here also. Why did we know this couldn't be 1? Oh, because it can't be 1, 2, and 4 here. This is then the pink 3, 7. So this can't be pink 3, 7. This is the pink 1, 9, which means this can't be the pink 1, 9. This is the pink 2, 8, which forces this to be the pink 1, 9, which means this can't be the pink 1, 9. It's the pink 3, 7. We don't know anything about these. This is the orange 1, 2, 8, 9, and this could be any of them. This is 2 modulo 3. We also have a 2, 8 pair in column 3 and a 3, 7 pair in column 3. That leaves the remaining digits as 1, 5, 6, 8, and 9. Okay. This cannot be a 5 because that is 2 modulo 3, and every 3 sets, 3 digits along a line of the modulo set can only have 1 of each modulo set. So this is either 1, 6, or 9. This cannot be 4. So the 6 has to be one of these two here to be the entropic line. So 6 must be one of these. And which one can it be next to a 1? It can only be here. So this must be a 1, which makes this 6. So the pinks are essentially the highs. And the oranges are lows. So this is 6. This is 1. This has to be high, so this is 8. This is 9. 7 here. This 1 means this is 9. This is 7. This has to be 3 then. 3 is next to 8, which makes this 2. 2 is next to 7, which is consecutive with 6. This is 4. This is 1, not 9. Which makes this 9. This is 8. This 6 eliminates 6 here, so that's 4. This is 6. This is 4. This can no longer be 6. We need... This is 6, so this must be middle. So this is 6, which means this is 0 mod 3. That means we have a 2 mod 3, a 0 mod 3. We need a 1 mod 3, and this can only be 1 then. This 7 eliminates 7 here, so this is 3. This can't be 8 or 9. This can't be 8 or 9. This can't be 7 or 8. This can't be 7 or... Oops. This can't be 7 or 8. This has to be high, and it has to be a 9. This is essentially a 4, because we don't have any other middle digit here. So this is middle. This is... must be high, and this must be low. So this is middle, this is middle, this is middle. These are both high, and these are both low. So this is low, this is high. This can't be 1, 2, or 3. Can't be 7, 8, 9. This can't be 1 anymore here. This can't be 9. This digit has to be a 5 because of the 4 in the box and the 6 in the column. That leaves this as 4. This has to be 5. This must be 6. 6 is only consecutive with 7 here. That leaves us as a low. It's 1, 2, or 3, but it cannot be 1 or 3, so this is 2. This can't be 2 here. This can't be 2 here. This must be a high digit and is 7. That makes this a low digit. So this is 7. This cannot be 7. So this is 8 or 9, 8 or 9. This is 1 or 3. And we have 1, 2, 3 here, 1, 2, 3 here. That leaves this digit as a high digit and this digit as a low. So this is 1 or 3. This is 8 or 9. It cannot be 9. So it must be 8, which makes this 9, which makes this 8. This can't be 8, so this is 2 because of the 8 in the column. This can't be 5. Okay, so we've done all the coloring that we need for the entropic lines and the German whisper lines. So we can remove those. These digits have to be 2 different sets on modulo lines. What can this be? It can be 1, 2, 3, 5, 6, 7, 8. 1 could be consecutive with 1, 2, 3, 4, no 5, 6, 7, or 9. But 9 can't be here. 5 and 6 can't be here either. Okay. It cannot be 1 and 2 because that would eliminate all possibilities for that cell. So this can't be 1. It could be 2, 3, 3, 4, or 7, 8. We're not sure which. Oh, this 4 eliminates 4 here, so this is 6. This 3 eliminates 3 here, so that's 2. This is 3. That eliminates, this 1 eliminates 1 here, so that's 2. This is 1. This cannot be 2. So this is either 3, 4, or it's 7, 8. Either way, this is 1 modulo 3, so this can't be 1 modulo 3. It's either 0 modulo 3, in which case it's a 3, or it's 2 modulo 3, in which case it's a 2. So this is 2 or 3. This can't be 2 modulo 3 because of the 8 being there. So it must be 3, 6, 9, or 7. Cannot be 9, so it's 3, 6, or 7 there. What else do we have? This can't be 6 here. One cannot be here. One can't be either of these. So where is the 1 in this upper left-hand box? It must be here. So this is 1. 2 has to be one of these digits. What are the remaining digits in column 2, possibly? 2, 3, 6, 7, 8, 9. Okay, this can't be 9. This can't be 2, 6, or 7. And this can't be 9 because of the 5, 6, 9 triplet in the box. This can't be 6, obviously, for the same reasoning. Okay, so where's the 4? 4 can't be here, can't be here, can't be here in this box, so this must be a 4, which makes this consecutive with a 3. That 3 eliminates 3 here, so this must be a 2. This 3 eliminates 3 here, so this is 8. This can't be 2, 3, or 8, so this is 7. 3 eliminates 3 here, so that's 1 and 3. This can't be 3 or 7, so that's 6. These can't be 1 or 2, so this is 3, which makes this 1, which makes that a 2. And the rest we can probably do by Sudoku. This 6 eliminates 6 here, so it's 5, which makes this 9, which makes that 6. The rest of row 1 must be 3, 4, and 5. And this can't be 3 because of the 3 in the column. No 5 because of the 5 in the column. No 4 because of the 4 in the column. This has to be a 2, 8 pair in row 3, which eliminates... But this can't be 2 because of the 2 in the column, so that's 8 and 2. Row 2, we are missing 1, 7, and 9. This can't be 7, this can't be 9, and this can't be 1. column 1, we're missing 5, 7, 8. This can't be 5 or 7, so this must be 8 in this cell here. Therefore, these can't be 8 here. In column 2, we are missing 3, 6, 9. This can't be 6 or 9 because of the 6 or 9 in the row, so this is 3. And this is a 6, 9 pair here. Okay, in this cell, we are missing 1, 2, 3, 4. We could have a 5 here. We can't have 6, 7, 8, and 9, so this has to be 5. This 5 eliminates 5 here, so it's 7 and 5. That leaves in row 7 the remaining digits of 2 and 8. This can't be 2 because of the 2 in the column, so this is 8, which makes that 2. This 5 eliminates 5 here, so this is 4. That makes that 3, which makes that 5. We have in row... Actually, let's do column 7. The remaining digits are 1, 6, and 9. Well, 1 can't be here, so this is a 6, 9. And this could be 1, 6, or 9. In column 8, we are missing 1, 7, and 4. 4 cannot be here, 4 cannot be here. Therefore, this is a 4. This can't be 1, so this must be 7, which makes this 1, which makes this 9. That makes this 6, which makes that 1. 6 eliminates 6 here, so that's 9 and 6. This 9 eliminates 9 here, so it's 7. And then we have 3 and 9 remaining. This can't be 3 because of the 3 in the row. This is 9. And we celebrate with 3 in the corner. Yeah, it's pretty nice. Pretty nice, pretty good use of the entropic lines and the modular lines with the German whisper lines to make an interesting little puzzle here. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.